Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Quinton, and I'm joined by Connor, and we'll be your host this evening, broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. Tonight is Science Night in Canada, where the lineup is all Canadian. Starting with ourselves, York Universe, we will then be moving on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning, 1 a.m. Universal time, for those of you listening from outside the Toronto area. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 p.m. and 10 p.m. local Toronto time. Go to www.yorku.ca/science/observatory and follow the links to OPV, online public viewing, to join the chat. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you may have, or to see our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter with our handle @YorkObservatory, or on Instagram with the handle @YorkUobservatory, and Facebook at Allan Carswell Obs. All of our programs are free, but if you'd like to make a donation, see our website at www.yorku.ca/science/observatory. So I am tuning in from the Greater Toronto area. I'm in Oshawa at the moment, and it's a partly cloudy night. It's about 22 degrees. What's the weather like for you, Connor?
Yeah, I'm here at York, and it's pretty clear as far as I think I can see. It's always hard to see if there are any clouds when you're looking at a dark sky, but it looks reasonably clear.
Nice. Yep. Oh, actually, sorry, my mistake. It's 18 degrees actually. They're expecting maybe some showers later tonight, maybe overnight. But right now, I think that it's decent conditions for maybe a little bit of observing. You might need to look for some breaks in the cloud cover. Perhaps if anybody's in the chat, perhaps they can talk about what the conditions are like for them if they're able to see anything in the sky right now. So Connor, do you want to just get right into the space and astronomy history?
I think that would be a good idea. It looks like we've got quite a lot lined up tonight.
All right, well then we better get down to it. I believe I'm on for the first item, so let's talk about it. So on August 10th, 1675, construction began on the Royal Greenwich Observatory in Greenwich, England. So we are talking about 1675. We were talking about, that's 350 years ago now. So I wanted to go with an event that's a little bit further back in the past to start off with. So the observatory was commissioned by King Charles II, and it was built in Greenwich Park, which was a royal estate and a former hunting park. King Charles also created the title of Astronomer Royal at the same time. And the first person who was appointed to this position was John Flamsteed, who is a English astronomer best known for his extensive 3,000-star catalog. The Astronomer Royal's responsibilities were to serve as the director of the observatory and to, quote-unquote, apply himself with the most exact care and diligence to the rectifying of the tables of the motions of the heavens and the places of the fixed stars, so as to find out the so much desired longitude of places for the perfecting of the art of navigation. So to translate that into simple English, essentially what they're talking about is that at the time, there was no reliable method of determining your longitude when you were at sea, because all the objects that you can see overhead, that might help you find your latitude, but those are all going to move across the sky from east to west over time, and that's going to look the same, regardless of how far you are to the east or to the west. So the majority of methods for calculating your longitude involve comparing the timing of certain events, like sunrise or midday to some known reference time. But without a reliable way of keeping track of time that doesn't depend on your position, this was really difficult. So astronomers made a little progress on the matter. They knew how to predict the timing of events like eclipse and transits, but this was impractical for navigation most of the time. The other way of solving the problem was by carefully measuring the distance to the moon, but this was very time-consuming, and it involved a lot of difficult calculations. It wasn't until the 1760s that chronometers that were able to reliably keep time at sea were invented. And this is still the preferred way of calculating your longitude to this day in situations where GPS is unavailable. So while the Royal Greenwich Observatory's work did not lead to the invention of the maritime chronometer, it did play an important role in the longitude problem. The prime meridian, which is the line of zero longitude, is actually defined as the line from the North Pole to the South Pole that runs through the Greenwich Observatory. The observatory was also used for timekeeping, and it gave rise to the name Greenwich Mean Time, or GMT, which all modern time zones are defined relative to. Although GMT has effectively been succeeded by the more precise coordinated universal time since the 1960s. So some of the observatory's other accomplishments include measuring the diameter of Mercury during its 1832 transit across the sun, and a long history of measurements of the Earth's magnetic field. Today, the observatory primarily acts as a museum for astronomical and navigational equipment, although the Annie Maunder Astrographic Telescope, located on the premises, has been used for astronomical research since 2018. Greenwich Park is now an enclosed green space in southeast London and a World Heritage Site. The position of Astronomer Royal still exists to this day, currently being filled by the cosmologist Martin Rees. So this is a nice little bit of history about like the legacy of astronomy and where we've come, really. A lot of the work that was being done in astronomy in around the time of the Renaissance was predominantly for the purposes of developing improved techniques for navigation at sea.
I will say that I took a look at the list of all of the people who have served as Astronomer Royal, and there are a lot fewer of them than I was expecting for a position that is 350 years old.
Yeah, that's what I was thinking. I was looking at this list, and the only other, maybe I'm giving away some of my own ignorance here, but the only other name I recognized on that list was Airy, the guy who also is known for inventing the Airy functions. I hope I'm pronouncing his name correctly. I thought, for some reason, I had thought that Newton was an Astronomer Royal, but apparently he wasn't.
Yeah, I do see this. The second Astronomer Royal was Edmund Halley of Halley's Comet fame.
Oh, I must have missed that. Oh yeah, of course, Edmund Halley.
Yeah, just like the incumbent here is, he's been serving this role for longer than I have been alive. So clearly, these people stick around for a long time, which is probably why there's only 15 of them in 350 years.
Good security. Sounds like okay. Did you want to do the next item?
Yeah, sure. So moving on to something a little bit more recent than the establishment of the Royal Greenwich Observatory. So for a little bit of history as a background here. So in 1999, NASA attempted to send 2 missions to Mars. This was the Mars Climate Orbiter and the Mars Polar Lander. Both successfully made it to Mars, but sort of these very embarrassing software problems resulted in the destruction of both spacecraft before they could actually begin their respective missions. These dual failures, which took place just about 3 months apart, led NASA to completely restructure its Mars exploration program, taking a slower and more cautious approach rather than just sending as many missions as they could every time a launch window opened. So one of the first components of the new 21st Century Mars campaign was the Mars Reconnaissance Orbiter, or MRO, which was launched 18 years ago on August 12, 2005. MRO is a dual-purpose mission, both conducting its own science by studying the present climate, looking for water, and mapping the planet's surface geology, as well as supporting other Mars missions by providing imaging and data relay services. To conduct its mission, MRO carries 6 science instruments. The star of its payload is the High-Resolution Imaging Science Experiment, or HiRISE. HiRISE is actually not just a traditional camera. It is actually a half-meter telescope, which is smaller than the one that we have here at York, but is still the largest to be deployed on a deep space mission. Rather than looking up at the sky, the HiRISE telescope looks down at the ground. From the nominal 300-kilometer orbital altitude of MRO, HiRISE can obtain images with an astonishing resolution of about 30 centimeters per pixel, which is comparable to commercially available satellite imagery of Earth. HiRISE is assisted in rover operations by taking multiple landings, by taking multiple images of different landing sites, for example, Gale Crater for the Curiosity rover and Jezero Crater for Perseverance, from different angles, which allows for high-resolution topography maps to be created, which can then be used by the rover teams to plan their driving routes in advance of arrival. However, the high resolution of HiRISE comes with a coverage trade-off. Despite being in orbit for 18 years, HiRISE has imaged less than 10% of the surface. For more global coverage, MRO also carries a context camera, or CTX. CTX has a lower resolution of approximately 6 meters per pixel and images in grayscale instead of full color like HiRISE does. However, CTX has now imaged over 99% of the Martian surface. Earlier this year, the Bruce Murray Laboratory for Planetary Visualization at Caltech announced the release of a global CTX mosaic, combining over 110,000 images from CTX to create a 5.7 trillion pixel map of Mars, the highest resolution map ever created for a planet other than Earth. The global CTX mosaic is actually available as an interactive globe on the Murray Labs website. Although CTX has imaged nearly the entire surface, it took nearly 2 decades to do so. To achieve global coverage faster, we need to step the resolution down even further. This is the job of the Mars Color Imager, or MARCI. MARCI's image resolution varies between about 1 and 10 kilometers per pixel, but images nearly the entire planet every day. MARCI's resolution is too low for most surface investigations, so MARCI's daily maps are primarily used to track weather patterns on Mars and to conduct other investigations of the Martian atmosphere. To investigate Mars's surface mineralogy, MRO also carried the Compact Reconnaissance Imaging Spectrometer for Mars, or CRISM. CRISM observed the surface at a resolution of 18 meters per pixel at a wide range of wavelengths from 360 to 3900 nanometers. Unfortunately, in 2017, CRISM's cryocooler stopped working, removing its ability to observe in the infrared and limiting it only to the visible. And in April of this year, CRISM actually reached the end of its useful life and was permanently shut down. The final science instrument carried by MRO is the Shallow Subsurface Radar, or SHARAD. Using high-frequency radio waves, SHARAD is able to penetrate up to 1 kilometer below the surface to look for ice and possible liquid water, as well as to investigate the interior structure of Mars's polar ice caps. In addition to all of the science, MRO also serves as a critical component of the Mars Relay Network alongside MAVEN, Mars Odyssey, and the Trace Gas Orbiter. Rovers and landers on the surface communicate with Earth through these orbiters, allowing for higher data transmission rates than when the surface assets talk directly to Earth.
That is so cool. The fact that we have the ability to image pretty much the entirety of Mars's surface every day. I know Marcy only gets like 1 to 10 kilometer per pixel resolution, but that's incredible. You generate daily maps of another planet. We've really done some really fantastic things.
It's daily maps for, like 18 years. So there's a phenomenally large data set out there that you can just, freely download.
Absolutely. And the fact that the context maps are down to, what did you say, 6 meters per pixel? And it's like,
yes.
and it's like, oh, well, this is a coarser resolution. It's like, that's six square meters in a pixel. That's a very, very fine resolution.
Mm-hmm.
That's incredible.
Yeah, 5.7 trillion pixels is a lot of pixels in a map.
Yeah, certainly.
I would be surprised even if, maps of Earth have that many pixels, because, they often, don't bother with high resolution imagery over the oceans for obvious reasons, but, Mars doesn't have any oceans, so you actually do have to image the entire surface at that resolution.
Well, I do know that I don't think it's down to the. I think it's not 6 meters, but there are actually some limits that they have to put on the at least the commercial maps that you generate of the Earth because you get down to privacy concerns if you're down to the point where you can resolve like down to the meter, right?
Yeah.
Like there's a certain level of detail because people live on Earth and on Mars we don't have that. We don't need to worry about that yet. There are limits to how well you're allowed to resolve features on the surface of the Earth if you're creating a commercial mapping system.
Yeah, I mean, like high-res, I know it is actually, that resolution is good enough that you can image the things that we have landed on the surface. Sometimes that's just done for fun, but it's also been really helpful when a mission has failed. You can send MRO over the landing site and image the surface and say, did this thing land? Did it crash into the surface? Is that why it stopped talking to us, or did it burn up in the atmosphere?
Hmm. This is fantastic. I sometimes I forget just how much infrastructure we have already set up to image the Martian surface and to learn more about these planets.
Yeah, and MRO isn't even the oldest of the satellites that we have in orbit. I think that goes to Mars Odyssey, which was 2001 is when that was launched.
Wow. Okay, so that's still within my lifetime. That's incredible. All of this within what, 22 years? That's incredible.
I mean, I know it is a concern for some people doing surface operation because a lot of these satellites that form the Mars Relay Network are getting extremely old. And so if even just one or two of them were to fail in the years, that would present a serious problem for our ability to return data from the surface of Mars.
Right, certainly.
And there have been proposals to send like a relay satellite that is specifically just for sending data from the surface back to Earth, but none of them have gotten very far because let's send a thing just to transmit data is not really something that gets a lot of people excited.
Right.
Compared to something that
there's
does
a limited
science
budget.
itself. Yeah.
Right. Do you want to move on to the next item?
Sure.
All right. So going back more than 100 years, I'm going to be talking about August 13th, 1898. So this was when 433 Eros was discovered. So this was actually 225 years ago yesterday. Was when the asteroid 433 Eros was discovered, and this was the first near-Earth object to be discovered. So on August 13th, 1898, the astronomer Gustav Witt of the Berlin Urania Observatory was taking a 2-hour exposure of the star Beta Aquarii, also known as Saddlesud, in order to measure the position of a different asteroid, 185 Uniki. And he discovered Eros during the process. And interestingly, another astronomer, Auguste Charlevoix, actually took a picture of Eros that same night. But Witt was able to announce his discovery first, so he got credited with it. And Eros was named after the Greek god of love and was the first asteroid to be given a male name. Up until this point, it was customary to name all asteroids after female mythological figures. So why did we make an exception for Eros? Well, because Eros had an orbit very different from all the previous asteroids that have been discovered. Eros is not confined to the asteroid belt. It has an elliptical orbit that allows it to cross over the orbit of Mars. Its perihelion is around 1.13 AU, astronomical units, meaning that it belongs to a category now called the near-Earth objects, which must have a perihelion less than 1.3 AU. Eros is elongated in shape and has a volume equivalent diameter of 16.8 kilometers, making it the second largest near-Earth object after 1036 Ganymede, which was discovered in 1924. So both Eros and Ganymede belong to a class of asteroids called the Amur group, which are all located strictly outside Earth's orbit and are incapable of impacting it unless their orbits change over time thanks to the influence of other objects. So the other classes of near-Earth asteroids are the Atiras, which are located entirely inside Earth's orbit and also at us, as well as the Athens and the Apollos, both of which cross Earth's orbit. So Atlas have a semi-major axis that is less than 1 astronomical unit, meaning they spend most of their time closer to the sun than the Earth is. And Apollos have a semi-major axis greater than 1 astronomical unit. So they spend most of their time, most of their orbit further away from the sun than the Earth is. For anybody who's unaware, an astronomical unit is the radius of the Earth's orbit. This is roughly the average distance between the Earth and the Sun. It's about 150 million kilometers, and the precise measurement of which, fun fact, was actually made thanks to Eris's help. Previously, measurements of the distance from the Earth to the Sun had been performed by observing the transit of Venus from different locations on the surface of the Earth and measuring the effect of parallax. But Eros is much closer to the Earth than Venus is, so a more precise way of measuring this parallax is possible if you observe Eros transiting across the Sun when it's closer to the sun than the Earth is. This measurement was performed for the first time in 1900 and 1901, and again in 1930 and 1931. The measurement of the astronomical unit measured in this observation remained the most precise one ever performed until 1968, with the development of radar and dynamical parallax methods. NASA's Near-Earth Asteroid Rendezvous Shoemaker probe, launched in 1996, visited Eros twice. It performed a flyby in 1998 and then orbited it in 2000 before landing on its surface in 2001 at the end of its mission. So this was the first time a near-Earth asteroid was closely visited by a spacecraft, and this is very fitting for the first near-Earth object to be discovered in the first place.
It is sometimes a little scary to think about, how many near-Earth asteroids there are out there that we probably don't know about yet. It seems like every few months there's a story that comes up like, oh, this tiny little asteroid just flew, within the orbit of, or within a geostationary orbit of Earth, and we didn't know about it until 3 hours before it happened.
Yeah, we're building infrastructure all the time to try to detect more of these near-Earth asteroids, but my understanding is that especially for objects that are coming from the direction of the sun, our detection methods are very bad. Because we don't, because obviously, it's very hard to see something if the sun is kind of blocking it out. And you really do have a full, a full sphere of directions that all these objects can be coming from. Because unlike the planets, the asteroids and the comets are not necessarily confined to the plane of the solar system. So they can come from, above, so to speak, or below, from the North Pole or the South Pole as well. So it's definitely a field that we are continuing to invest more resources into.
It's definitely a very challenging technical problem because, once something is, that small, there's only so much you can do to see it.
Yes, certainly. You want to take the next item?
Sure. This is just a short one, but a very Canadian one. So this past Saturday, August 12th, was the 20th anniversary of the launch of SciSat-1, which is an Earth-observing satellite operated by the Canadian Space Agency. The primary science mission of SciSat is to study Earth's atmosphere, which it does by observing the sun as it rises and sets during each orbit that the spacecraft makes around Earth. As the sun's light passes through the atmosphere on its way to SciSat, it interacts with the various gases in the atmosphere, interactions that SciSat can measure by comparing with spectral observation of the sun made when the atmosphere is not in the way. These measurements are conducted using SciSat's two instruments that make up the Atmospheric Chemistry Experiment, or ACE. The first is the Fourier Transform Spectrometer, or FTS, and the measurements of aerosol extinction in the stratosphere and troposphere retrieved by occultation, or MAESTRO. So SciSat has spent the last 2 decades observing everything from ozone depletion and the concentration of the various chlorofluorocarbons and hydrofluorocarbons that are responsible for the depletion, to aerosols injected into the atmosphere by wildfires, and recently monitoring the vast quantity of water vapor that was thrown into the stratosphere by the January 2022 eruption of the Hunga Tonga volcano. Although SciSat's mission was originally planned to only last 2 years, it has been extended through at least next year. And just as a fun local connection, SciSat is managed in part by teams in Toronto, including at the University of Toronto and right here at York.
I know that York has a pretty impressive atmospheric science division. I imagine that they had some connection to that, right? I think that, in fact, I think I may have seen some of their posters up talking about this program in the science building.
There are lots of posters around about the many different missions that we participated in.
I, I always find it funny when I read about some of like the scientific equipment that we put into space. You can tell that there's like there's definitely a drive to give every mission some kind of snappy acronym. Like I'm looking at this like Maestro, Ace, Marcy was with the Mars orbiter. I mean, Maestro, like I don't know, I think it works, but sometimes I notice they really need to cram it in there. They need to kind of get creative with their acronym conventions in order to give them a nice catchy name.
I think there's often a lot of backronyming where they come up with the acronym first and then they try and invent a name that will fit into it.
Yeah, definitely.
It's definitely a thing that is prevalent in all of astronomy. I think there's someone at Harvard who maintains a list of the most just outlandish acronyms in astronomy, and some of them are really like, you're really pushing the limits of what can reasonably be considered an acronym.
That's very good. I should check that out later. So, it's funny that you talked about this because the next item on the list also has to do with atmospheric science and specifically using space probes to study the atmosphere of planets. I'm referring to the Magellan probe, which did not measure the Earth's atmosphere, but rather the atmosphere of Venus. So 33 years ago, on August 10th, 1990, the Magellan probe entered the orbit of the planet Venus. Magellan was a space probe launched by NASA on May 4th, 1989, with the objective of measuring the Venusian gravitational field and mapping its surface using radar. So scientists have been advocating for a radar mission to Venus since the 1970s, but NASA's first proposed mission to generate radar maps of the surface, the Venus Orbiting Imaging Radar, or VOIR, not a particularly clever acronym there, was canceled in 1982 as it was not within the agency's budget. So a simpler mission was proposed in 1983, which in 1985 was renamed Magellan Program after the Portuguese explorer who circumnavigated and mapped the Earth. The Magellan probe's objectives were to capture radar images and topographic maps of nearly the entirety of the Venusian surface, as well as to generate gravitational field data for most of the planet. Because Venus has a thick, opaque atmosphere, its surface cannot be imaged using conventional optical survey, which is why the probe was outfitted with a radar system. So the resolution of a radar signal is typically limited by the size of the antenna, and it was not possible to get a high-resolution scan of Venus using a radar antenna small enough to fit on the Magellan probe. So the probe relied on synthetic aperture radar, in which the antenna is moving quickly, and this motion over the surface of Venus allows the system to behave as if there is a much larger artificial or synthetic radar antenna, that is the aperture, and generate a higher resolution image. So the probe was able to map 98% of the planet's surface to a high degree of detail. So after entering orbit on August 10th, Magellan began its first mapping cycle on September 15th, completing it on May 15th, 1991. By the end of the first mapping cycle, Magellan had imaged approximately 83.7% of the surface. It proceeded to carry out 5 more mapping cycles between 1991 and 1994, filling in gaps in the existing map and collecting gravitational and radiometric data. These data allowed the scientists to discover that the surface of Venus is primarily covered by volcanic materials, with large lava channels and volcanic domes. There are very few craters on the planet's surface, indicating that it is quite geologically young. And when it has tectonic activity, this takes the form of global rift zones and broad upswellings rather than the plate tectonics that lead to continental drift on Earth. So by September of 1994, the probe had completed all mission objectives, and the solar arrays had degraded significantly. The probe entered the final phase of its research, the windmill experiment, where its orbit was lowered significantly and the probe was oriented, so its solar arrays were aligned perpendicular to the orbital path. So this acted as an aero brake, and information on the dynamics of the system were used to study the impact of upper atmosphere forces on satellites. The experiment lasted 2 weeks, and then a series of orbital trim maneuvers were carried out that progressively lowered the probe's orbit until, on October 11th, 1994, the craft was placed well within the Venusian atmosphere, which would destroy it. Much of the craft was expected to burn up in the atmosphere, although some wreckage from the craft probably remains strewn across the surface of Venus to this day. Little pieces of our handiwork on an inhospitable alien world. So I thought it was kind of coincidental that this landmark for the Magellan mission and the Mars Reconnaissance Orbiter that you were talking about earlier, and I guess to a lesser extent the SciSat, which was studying Earth's atmosphere as compared to Magellan studying Venus's atmosphere, that these all happened around the same time of year. It's kind of interesting, similar mission objectives, really.
And Venus has been, I think, criminally underexplored relative to other planets. Just looking at the list, and since Magellan, I think there have only been 6 other orbiters sent to Venus, which really is not very many when you compare it to somewhere like Mars, where it seems like we are sending things just constantly every single year. I know there are like there is the upcoming Veritas and Da Vinci probes, but those have been plagued by all these these budget problems that the Planetary Science Division has been having. The Veritas mission crew, they're really pushing for this because we don't study Venus as much as we really should for a planet that is very close to us and very similar in size, but it's radically different from Earth.
Yeah, that's true. Venus. I remember they used to call Venus. I don't know if they still do, but they used to call Venus Earth's twin because it's so similar in mass. But obviously, it's very, very, very different conditions. I do suspect maybe part of the reason why Venus has had comparatively fewer probes sent to it as compared to Mars is because Mars is just more charismatic, right? Mars is the one that is seen as the one that we're going to be living on someday. Venus is this inhospitable, uninhabitable, blazing hot planet. And when you are working with a limited budget, a lot of the time you do kind of have to appeal to the public imagination, kind of what really catches the eye of the public, even though it's quite clear there is a lot of very, very valuable information to be gained from studying Venus, in terms of its contributions to planetary science. So it's one of those things that is a little bit disappointing about the fact that we do still have to work with the budget that we're given, because there's so many projects that are worthy of study. But it's just very difficult to figure out how do you prioritize all that when you have a limited budget to work with, Yeah,
I feel like landers will generally will generate more publicity than an orbiter will.
Yeah,
and
certainly.
Venus is a challenging place to put a lander that will survive for any extended period of time, where extended period of time could be a day.
Yeah, exactly. It kind of feels like sacrificing a lander to Venus. You just kind of toss it into the inferno.
There have been some fun proposals to send balloons into the atmosphere and do science from within the atmosphere, but not so far in that it becomes dangerous for the spacecraft.
That would be very interesting. I wonder if we could do something like that with Titan as well.
Yeah, because I know you can get well into the Venusian atmosphere and at still a reasonable altitude, surface temperature and pressure are not dissimilar to what they are on Earth. So you could, in theory, have a spacecraft, floating over the surface, if not necessarily on it.
All right, maybe we'll see that happen. That'd be exciting. All right, I believe we have one more item in the This Week in History, and then we should move on. You want to take it away?
Sure, yes. It's a very launch-heavy episode this week, as August 20th, 1975 marks the 48th anniversary, this August 20th will mark the 48th anniversary of NASA's Viking program, which began on August 28th, 1975, when the Viking 1 spacecraft was launched on board a Titan III Centaur rocket from Launch Complex 41 at Cape Canaveral. Like its later twin, the Viking 1 mission actually consists of two spacecraft, a lander and an orbiter. The two components flew together on the 11-month journey to Mars before the lander separated to perform science from the surface. Originally, touchdown of the Viking 1 lander was scheduled to occur on the United States bicentennial of July 4th, 1976, but unfortunately, initial imaging of the planned landing site from orbit indicated that the site was likely too dangerous for the lander. Thus, landing was delayed while the mission's team used the orbiter to look for a safer site. The Viking 1 lander eventually touched down in Planitia on July 20th, 1976, which is the 7th anniversary of the Apollo 11 moon landing. And this was the first time that a spacecraft had successfully landed on Mars. Viking's landing system was much more complex than one might assume that it had to be. While the lander was sufficiently lightweight, that landing could have been accomplished with just a single rocket engine, like what was done with Apollo. The task was instead divided between 18 different rockets. This was done because it was believed that 18 smaller rockets would have a smaller impact on the surface than one large rocket. When you're a stationary lander that can only poke at the ground near your landing site, it's important that you contaminate the site as little as possible, or else your experiments might be measuring your own presence on the surface rather than the actual properties of the surface itself. Following landing, the Viking 1 orbiter remained in orbit, taking pictures of Mars until it was decommissioned on August 17, 1980. Prior to decommissioning, it was raised into a higher orbit to prevent it from colliding with Mars and potentially contaminating the surface. It may actually remain in orbit to this day, although it has not been observed by any of the fleet of spacecraft that is now orbiting Mars. The lander operated on the surface for 6 years until an unfortunate accident occurred on November 11, 1982. As the lander aged, its battery capacity deteriorated, which put the future of the mission at risk. New software was written for the lander that would change the way that its battery charged, which would hopefully further extend its life. However, an error in the uplink command resulted in the new charging software overwriting the lander's antenna pointing software, meaning that it could no longer communicate directly with Earth. Had the orbiter still been functioning, it may have been possible to continue using it as a relay between the lander and Earth, but without anything in orbit, the link between Viking 1 and Earth was permanently severed. Despite this undignified end to the mission, its longevity would not be surpassed until May 19, 2010, when the Opportunity rover began its 2,246 sol on Mars. Perhaps the most unusual result from the Viking 1 mission came from the lander's biological experiment. This experiment consisted of three components in addition to the lander's general gas chromatograph mass spectrometer, each of which would look for life in their own unique, independent ways. The spectrometer, the pyrolytic release experiment, and the gas exchange experiment all returned negative results, but the labeled gas experiment returned a positive result. This experiment monitored a sample of soil that had been dosed with a small amount of a solution containing 7 nutrients that had been labeled with radioactive carbon-14. The release of radioactive carbon dioxide gas from the soil was a potential sign that microorganisms in the soil had metabolized the nutrients, although the fact that the other 3 instruments had all failed to find any evidence of life complicated the story quite a bit. Although it is now generally believed that the results of the labeled gas experiment were caused by abiotic chemistry unique to Mars, there are still those who believe that Viking 1 did in fact discover life on Mars.
Yeah, that's. I mean, we all want to hope, right? It'd be nice to get a more conclusive result than that, certainly. But hey, who knows? Maybe there's life in all kinds of crazy places on Earth, so I don't know. Why not?
It would be an extraordinary claim, and they say extraordinary claims require extraordinary evidence, and I think 1 positive out of 4 is probably not that extraordinary evidence.
No, that's not really extraordinary evidence. Which is why we need to send even more missions there, because I don't know, maybe we'll find something this time around, right?
Hey, there's the whole phosphine debate on Venus about whether or not that's biotic or not. So maybe we should be sending more things to Venus.
That's a good point. That's a really good point. Maybe we should just send probes everywhere. As many probes as we can, absolutely everywhere. All right, folks. Well, I just wanted to remind you all you are listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. You can visit our website, www.yorku.ca/science/observatory for our chat. If you want to ask any questions and to take a look at all the content that's on there. Our Astronomer in Residence blog, which details the exciting adventures our astronomers are having at Killarney Provincial Park, can also be found on the website. This week, the Astronomer in Residence is a regular York Universe host, Julie Tomei. So be sure to check her blog to learn all about what's going on up in Ontario Park's first dark sky preserve and to see some beautiful nature images and astrophotography. You can also follow us on Twitter at YorkU Observatory. So tonight you're listening to Connor and myself, Quentin, and we're currently discussing astronomy history. You should swing by www.yorku.ca/science/observatory and click on online public viewing on the menu bar for OPV. And there you can join our chat room, talk to all the observatory staff who are going to be in that chat room, answering any of your questions, sharing astrophotography images. It's a really nice place to hang out if you're interested in astronomy. So, Connor, we've talked about quite a few events in astronomy history, but I am personally really, really excited to talk about some recent news. Are you ready to move on?
I sure am.
Oh boy. Okay. So this when I found out about this, I was like, okay, I need to talk about this on York Universe. So, an article published in the Astrophysical Journal on July 24th by Kyu-Hyun Che of Sejong University appears to demonstrate a breakdown in the theory of gravitation predicted by Newtonian mechanics and general relativity for very low gravitational accelerations. So using the European Space Agency's Gaia Space Telescope, Che studied the motion of long-period, widely separated binary stars and calculated their gravitational acceleration as a function of their separation from each other. Using a sample of over 20,000 such binary systems, Che found that in systems where the acceleration was lower than 0.1 nanometers per second squared, so very, very low accelerations, the observed acceleration was actually 30 to 40% higher than what general relativity predicts. But the data agreed with general relativity's predictions for higher accelerations, so anything above 10 nanometers per second squared. Two independent acceleration bins show deviations from the model in the same direction with significance above 5 sigma. And this is important because in particle physics, at least, this is the standard of statistical significance required to declare that a result represents a real discovery. So why is this finding so important? Well, this breakdown of the Newton-Einstein model of gravity for accelerations lower than 0.1 nanometers per second squared was actually a prediction made by the theoretical physicist Mordechai Milgrom in 1983. And he published his theory of modified Newtonian dynamics, or Milgromian dynamics, in that year. More specifically, the data are consistent with the quadratic Lagrangian theory of gravity, also known as AQUAL, which presupposes the existence of an external field effect from the Milky Way galaxy predicted only by Milgromian dynamics. So Milgromian dynamics, most interestingly of all, were designed to provide a theoretical explanation for the anomalous behavior of galactic rotation curves without postulating the existence of dark matter. So does this mean dark matter doesn't exist? Well, as always, we should avoid being too hasty. A result with such huge implications for cosmology requires independent confirmations of Che's results before it should be accepted as scientific fact. Still, it has very interesting implications for one of the most mysterious topics in astrophysics, and I know I'll be following along with the development of the situation eagerly. If dark matter were shown to fail to be necessary to explain the phenomena we see in the universe, and again, it's way too early to make a definitive claim like that at the moment, this would completely upend our understanding of the matter content of the universe and require us to seriously overhaul our models of cosmological development in order to account for the Milgromian behavior of the gravitational force. So we might potentially be at the precipice of a complete paradigm shift in cosmology. We might be looking at a universe where dark matter, which we've been searching for and trying to understand the fundamental nature of, we might be looking at the possibility of a universe where dark matter doesn't need to exist to explain the results we see at all. Again, very early. Don't want to call it or anything yet, but watch this space because I have a feeling that this is going to be interesting no matter how it shakes out.
I'm always fascinated by these kind of discoveries that use spacecraft in a way that they were really not designed to be used in. Gaia's primary mission is astrometry, actually measuring the positions, distances, and motions of billions of stars in the Milky Way with this sort of unprecedented resolution. It was not meant to, potentially upend our theory of gravity.
Yeah, but it's just like the James Webb Space Telescope was not was designed for like very high redshift observations of distant galaxies. But we've been able to use it, just the fact that it keeps getting hit by like micrometeors. We've been able to use it to update our models for how widespread these micrometeors are within the solar system. So even something that's negative, like your telescope getting hit by a bunch of little rocks, it's still something that you can gain really useful scientific data from. I think that that really says a lot about the way science is done.
And I know, like, for example, the Juno spacecraft, when it was on its way to Jupiter, they found that there was, this interplanetary dust that was chipping off bits of the solar panels. And so by measuring the rates of those impact events, they were actually able to, create this map of interplanetary dust between the Earth and Jupiter.
Yeah, I mean, data is everywhere. You just need to analyze it, right?
Yeah, and I know Gaia itself has also been used for like exoplanet discoveries because, as it turns out, when you're observing distances to stars, billions of them over a large portion of the sky, you're going to catch a lot of exoplanet transits and a lot of radial velocity events.
All right. Do you want to move on to the next item? I'm looking at it. It's really sad. So I understand if you want to delay it a little bit longer, but
it is a bit sad, but I think it was probably coming.
Yeah.
So this is regarding the Arecibo Observatory. Famously, on December 1st, 2020, after years of deferred maintenance, the famed Arecibo radio telescope suffered a catastrophic failure that sent its instrument platform plummeting into the dish below. Following the destruction of the telescope, the National Science Foundation decided in October 2022 that it would not be providing the funding necessary to rebuild it. Instead, the observatory was to be converted from a research center into the Arecibo Center for STEM Education and Research. However, the approximately $1 to $3 million that are needed each year to run the proposed facility have yet to materialize, leading to concern among many the whole site will be permanently shut down. Indeed, as of today, Monday, August 14th, 2023, the observatory's computer systems were turned off for the last time, which officially brings the 60-year history of astronomical observing at Arecibo to an end.
That's really unfortunate. It's the end of an era. Now, I remember hearing about the news when the telescope collapsed. Everybody was talking about it in the WhatsApp chat. Everybody was kind of expressing their regrets to see that such a thing had happened to this historic observatory that has done so much important work. And it is unfortunate to hear that we're essentially, I guess, throwing in the towel now. But you know what? 60 years of history, all that research, that hasn't gone away, right? We still have all of that data. We still have all of those accomplishments. So it's not like all is lost.
Yeah, I mean, it was a bit sad because, Arecibo, the big telescope, was not the only one at the observatory. There was actually another smaller radio telescope that was still functional after the big one collapsed. But, without any of the money needed to run the observatory, they had to turn that one off too, even though it was still fully functional and, doing science.
Yeah, I mean, so what we were talking about earlier, right? Budgets. There's so much fascinating science out there that we really want to do, but budgets are limited, and you do have to make some very difficult decisions about where you're going to prioritize spending that money. So it's unfortunate, but it is what it is.
Yeah, and Arecibo was famously just plagued by budgeting issues through its last few decades of existence. So maybe not surprising that once it collapsed, that everyone the National Science Foundation just decided to wash its hands of the whole thing and just call the whole project to an end.
So do we know what is happening to it? You said that the museum is the museum still a possibility, or are we just leaving it?
I think it's still in the books. I think they are. I think there's a really skeleton staff of like maybe 13 people
Hmm.
still on site to like keep the buildings up.
Right.
So I think it's not we're not like totally abandoning it, but like as of this moment, there is no solid, budget in place to bring this, STEM education and research facility to Arecibo.
Hmm. Well, I hope we get some kind of educational facility eventually. It'd be a shame to just, after all that work that's been done there, to just kind of just leave it to leave it to sit, you know.
Hmm.
All right. Shall we move on with the next item?
Sure.
All right. So astronomers have known for a long time that around half of the stars in the galaxy belong to systems of more than one star. We call these multiple star systems. So stars form in the dense cores of molecular gas clouds, and while multiple star systems consisting of more than two members are not uncommon in the universe, for a long time the details of how these systems form were unknown due to an absence of data. So a team of research from the ALMA survey of Orion Planck galactic cloud clumps, or ALMASOP, led by Professor Liu Tie from the Shanghai Astronomical Observatory at the Chinese Academy of Sciences, has discovered a forming quadruple star system in one of the dense cores in the Orion molecular cloud complex. So in a press conference put out on the 7th, the team described the system as consisting of two protostars and two prestellar gas condensations that may develop into low-mass stars in the future. The system is exceptionally compact, with a separation of only around 1,000 astronomical units between the bodies. The objects appear to be linked together with long continuum ribbons of accreting material, which bring gas from the outer core into the prestellar condensations and will likely continue to feed them until they develop into full stars. Similar ribbon-like structures have been found in more developed quadruple star systems. It's also possible, actually, that the ribbons could end up fragmenting and creating additional gas condensations, potentially adding more stars to the system as it matures. So we finally found a young quadruple star system, one that is not yet completely formed. And it appears that these accretion ribbons they begin very early in the system's development, which isn't really much of a surprise because that's where the accretion process, really needs to happen in order for the star to even, come into existence. I don't know. This is very fascinating. I'm hopefully we continue to find more examples of these so that we can study how multi-star systems like really emerge. I'm curious to know like how long it'll be before we find like a young 5-star system or a 6-star system, because I do know that the probability of finding a multi-star system within a dense cloud is inversely proportional to the number of members in that system. So I believe it's something like there's about a third as many 3-star systems, there's about a quarter as many 4-star systems. So it falls off. The more stars are in the system, the more unlikely you are to find them.
I know that Castor, the second brightest star in Gemini, is actually a sextuple star system. So
Wow.
that's 6 stars all orbiting in various combinations. So you really have to wonder, like, how does something like that both form and remain stable over a long period of time? Because the sort of, gravitational perturbations in that system must be very fun.
We thought Gemini was the twins. It turns out they were septuplets. That's I don't know. That is really fascinating. The other thing is I've seen some of the work done on what kind of planetary systems could at least theoretically form inside multiple star systems. And there's all sorts of different configurations to it because you could have the planets orbiting one star or the other, kind of like the way that the planets in the solar system orbit the sun. But you could also have planets orbiting the common center of mass of the system. This is for a binary star system. But if you move up to like higher degrees, it becomes way more complicated. Like already, even without taking any planets into consideration, when you get to a triple star system, you're dealing with the three-body problem, right? Like this is already essentially an unsolved problem in gravitational physics. So even just understanding the orbits of those stars around each other is very difficult. If you're trying to understand how the planets are going to interact with each other within that system for long periods of time, it's very, very complicated. But the kind of like solar systems that might exist out there really is interesting to think about. And it kind of seems like our imagination is really does have a lot of free reign here, because we know that these multiple star systems are very common. We have no reason to believe that planets wouldn't form frequently within these star systems. So there's probably all sorts of crazy things out there that it's interesting to think about, you know?
I mean, if the stars in, like, for example, a binary system are, you know, separated by far enough, you could easily form a solar system around one of the members and, you know, basically have it not too dissimilar to our own.
Yes.
I know there were some, you know, these big, you know, conspiracy theories about, you know, the sun actually having a binary companion.
Yes.
You know, someday it'll come in and
yes.
cause the apocalypse. As it'll just, you know, scatter the asteroids and the planets all over the place.
Yeah, my understanding of that situation is the sun would not have a binary twin that would be able to pass into the inner solar system and do anything like that. But I did hear that it's actually a more open question if the sun might have some kind of very dim companion star that's much further out and that does not and that wouldn't make a close approach like that. I don't want to speak concretely on this because this is not something that I've done a whole lot of research on, but it is interesting that like it seems like that possibility, not of it be causing the apocalypse or anything, but the possibility of there being a companion to the sun is not necessarily ruled out, in much the same way that it's possible there could be like a ninth planet in the solar system that's much further away. I don't know. I would suggest anybody listening do their own research on this from credible sources, because I don't want to put any ideas in people's heads that I can't back up.
It's again that same problem of small, faint objects that are very far away.
Yeah, absolutely. So, do you want to talk about the two supermoons in the same month? We've got about 3 minutes left.
Yeah, this could do this real fast, I think. So yeah, earlier this month, you might remember at the beginning of August was a supermoon. This is not too terribly unusual, but what's special about this month is that we are actually getting two supermoons in 1 month. This is fairly rare because it requires both there to be two full moons in 1 month, which is already reasonably uncommon.
Happens once in a full moon.
And then on top of that, you also have to have both those full moons occurring when the moon is at periapsis, or its closest point to the Earth. So the last time that this double supermoon happened was in 2018, and it will not happen again until 2037.
Wow. So I believe the first full moon was on August 1st, and the second one will be on August 30th. So literally right at the beginning and right at the end of the month.
Well, you know, given the length of a lunar month, is sort of the arrangement that you need to have two.
Absolutely. All right. Well, everyone, you've been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Connor and myself, Quentin. Stay tuned, because it is Science Night in Canada. Coming up next is Western Worlds, Quirks and Quarks, and Science for the People. You can always connect with us on Twitter with the handle @YorkUniverse, Instagram with the handle @YorkU Observatory, and Facebook @Allan I Carswell Obs. And check out our website for show notes, content, updates, and contact info at www.yorku.ca/science/observatory. I once again want to plug the Astronomer in Residence blog, which is accessible on the website. I was an astronomer in residence back in July. I had a fantastic time. I kept a very meticulous blog. I've got lots of information up on there. So if you're interested in learning more about what it's like to stay at a dark sky preserve in near Georgian Bay, you should check it out. We have our very own Julie Tomei up there right now. She may have already put up her first blog post because she just arrived today. So by all means, give that a look. But with all that said, thanks for tuning into York Universe. Clear skies and have a good night. Goodbye.
Night, everyone.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.